For question 8, we are given that f of x is equal to x in brackets x minus 3 squared with first derivative at values of 1 and 3 being equal to 0. And we know that our function at the value of 1 is equals to 4. And this is the information given to us over here. First question, they want us to show that x is equal to 2 is a point of inflation on our f of x. Now, and a point of inflation is where our graph either changes from concave up to concave down. So let's say that's our point of inflation. Then our graph is changing from, let's say here, concave up, I mean down to concave up. Or our graph is changing from concave up to concave down. That is our point of inflation. Now, one thing again we know about our point of inflation is that the second derivative, that value of x, let's say the value is equals to a, our second derivative will be equal to 0 at that point of inflation. So for our graph, let's go ahead and simplify it first before we look for derivatives. Okay. So you square the first one, you multiply these two together. So x multiplied by minus 3, giving you a negative 3x. Then you multiply that by 2, giving you a minus 6. Then you square the last one, you get a positive 9. Let's go ahead and multiply out with the x. We get squared plus 9x. For our first derivative, we multiply the exponent with the coefficient and we minus 1 from the exponent. We multiply the exponent with the coefficient and we minus 1 from the exponent. And again, we multiply the exponent with the coefficient. We minus 1 from the exponent, which will give us x to the power of 0, and anything to the power of 0 is 1. For our second derivative, we multiply the coefficient with the exponent, and we minus 1 from the exponent. Then we multiply, and we minus 1 from the exponent. And any derivative of a constant is always equal to 0. So now we have our second derivative. We will then take our second derivative and equate it to 0 so that we can find at which x value is our point of inflation at. Then we get 6x is equals to 12. Divide both sides by 6. We get that x is equals to 2. Now let's prove that this is correct. Right? So we will prove it by showing that on the left-hand side of our x, we either have a concave up or a concave down in terms of this. Or again, it could be this way. On the right-hand side, there's a concave up, and on the concave up, down, sorry, and on the left-hand side is a concave up. So let's just, how do we prove that? If our second derivative is greater than 0, then we know we have a concave up. And if our second derivative is less than 0, then we know we have a concave down, depending on the values. So now, because we're looking at 2, we will start by looking on our left-hand side by putting in values that are lower than 2. Now, in the answer sheet, they used 0. So let's also use 0. Again, derivative. Giving us a minus 12, telling us this side is a concave down. Okay, and for the other side, they use 3, anything greater than 2. And we get a value of 6. So we have a concave up on that side.